All right, up next, we are joined by JP and Severin. JP is the founder and CTO at Pipekit, and he's an ex-Docker engineer. Severin is the senior infrastructure architect at ACCURE Battery Intelligence, working mainly in the areas of cloud, data, and DevOps engineering. Before that, he was an academic researcher in the field of data-driven energy systems analytics, in particular, the integration of renewable energy sources into large-scale power grids. That sounds really interesting. Welcome, gentlemen.
Thank you so much for the intro. All right, I'm JP Zivalich, and I'm accompanying Severin Ryberg. Today, we're going to be talking about processing petabytes in Python with Argo Workflows and Dask, and we'll be doing a deep dive into how ACCURE Battery Intelligence runs its analytics for its customers. So without further ado, let's jump into our introductions. I'll kick it to Sev.
Thanks. Actually, I think most of the introduction was already covered on my half. I think the only thing that wasn't mentioned already was before going to ETH for my PhD. And before that, I was at Texas Tech University, where I studied physics and electrical engineering. But I think all these other points were hit. So thank you for that. JP, back to you.
And yeah, likewise with my intros as well. Yeah, aside from Pipekit and Docker, I went to Notre Dame for my undergrad. I'm based in Atlanta, Georgia. And if you want to get in contact, the best way to do it is through the CNCF Slack channel. So next we'll talk a little bit about our companies and what they do.
Yeah, so ACCURE Battery Intelligence monitors battery fleets on behalf of our customers. And basically, we use our battery know-how to create some computational algorithms to compute useful metrics for batteries. So this can include things like computing the state of health of batteries, coming up with safety alerts, and coming up with some optimization, or rather operation optimizations. And our basic goal is to make batteries smarter. And in case anyone is interested in this sort of work, we are hiring, and for remote. We're based in Germany.
Nice. And at Pipekit, we are a control plane for Argo Workflows targeted at data teams. We help provision and manage workflows on multiple clusters, or if you want to run workflows on your end customers' clusters, that's a use case that we handle as well. ACCURE is one of our earliest pilot customers. We're really fortunate to be working with them and working with Severin. Currently, we're in a closed beta, but we are accepting new customers. So if you're interested, please reach out. So next, I'm going to go over some of the goals for this presentation. So first, we want to understand how to run highly parallelized frameworks on Argo Workflows. Today, we're going to be focusing on Dask because that's what ACCURE Battery Intelligence is using. But similar frameworks that you might be using at your organization might include Spark, Hadoop, or any one of these sorts of types of things. Additionally, we want to talk about configuring multi-tenant data environments on Kubernetes using Argo Workflows. So if you need to run several different customers' workloads on the same cluster, we'll be talking about that. And then lastly, we'll get into the design of a simple scalable Dask pipeline using Argo Workflows. Real quick, I'll cover the outline. So first, we'll be talking about what the requirements are for ACCURE Battery Intelligence once we do this engagement. Next, we'll talk about provisioning Argo Workflows and the needed cloud and Kubernetes resources. After that, Severin will go on a deep dive about the Dask setup. We'll be following that with an interactive demo, and then Severin will give his concluding remarks. So I'll kick it to Sev to talk about the requirements.
Yeah, so before we even thought about which tool we would want to use to service our data processing at ACCURE, we of course had some boxes that we knew that we needed to check. So we knew that we wanted to stay in Python, and we wanted to avoid the situation where we switch between Python and other environments, such as how Spark does in the backend, switching between Python and the JVM. We also knew that we wanted to go beyond simple MapReduce type functions. So especially in the battery world, we have lots of heuristic algorithms that we need to implement, and we just simply wouldn't be able to do that if we were limited to simple functionals. We also knew that we wanted to have the same, if not a similar, development experience between both testing and production environments. And what this really comes down to is we want to write code once and have it work whether we're invoking it in a sequential situation, where we just have one computer where everything is running sequentially, all the way up to we have a distributed cluster of computers that are all working together on the same pipeline. And we want to use the same code for all of these contexts. We also knew that we wanted to conduct both batch processing, where we have many independent tasks that run parallel to one another, as well as shared parallel processing type workloads, where we have one big task that many workers help to solve all at the same time. And lastly, to reduce friction within our organization, we wanted to promote self-service, especially for our Dask engineers, data engineers, whenever possible. So we wanted to remove bottlenecks such as a data engineer needing to talk with someone on an infrastructure team to provision cloud resources so that they can do their day-to-day work. Yeah. So back to JP for infrastructure.
Thank you, Severin. I'll be going over the infrastructure and security requirements that ACCURE Battery Intelligence had. The first is ultra-low latency parallelization. So ACCURE is running workflows that spin up a ton of different subtasks and subjobs. And within a pure Argo kind of mindset or cloud native mindset, we would be doing each of those in a pod. But that is a little bit heavyweight for the workflows that we're running. Pods on average have spin up times of usually between 2 and 10 seconds. And so if you're running these massively parallel jobs, that can slow down the workflow run greatly. With one of the workflows that we're going to be showing you, let's say maybe it takes hours, and then we would be, going to days if we were going to do that in a pure cloud native context. So additionally, we need to set up pools of pods for highly parallelized operations. So allocate a pod pool and just submit jobs to that rather than having to spin them up and down. Next, they needed a multi-tenant environment. So specifically, they need to be running different customers, workflows on the same Kubernetes cluster, but they need to have good separation amongst the different workflows so that one workflow doesn't have the ability to access resources that belong to a different customer. And then lastly, this all needs to be production ready. So we need things like good logging that's accessible in ACCURE's Elk stack, highly dependent or super dependable scheduling, and workflow run archiving. So if there's anything that needs to be troubleshooted, that ACCURE can do that. So next, I'll do a little bit of a deep dive on provisioning Argo Workflows and the other cloud resources. So first in our provisioning, we're doing infrastructure as code. ACCURE Battery Intelligence is using GitLab to store their workflow configuration, Kubernetes configuration, and the Pipekit daemon that does some of the managing of Argo Workflows. For the actual spinning up and down of resources, we're using Pulumi, but you could use Terraform or CloudFormation, or really any tool that you'd like. We're doing a cluster-wide installation of Argo Workflows, meaning that we install the workflow controller and the Argo server in a cluster scope, and then we're provisioning a namespace for each customer that ACCURE Battery Intelligence is serving. So operators, meaning people that work on ACCURE's side, have access to creating, updating, and deleting workflows and workflow templates in each namespace. But these individual workflows don't have the ability to access other resources within that Kubernetes cluster. So that brings us into that customer-specific namespace thing. Additionally, I want to call out that they're using cron workflows to trigger workflow templates. And each of those cron workflows are sitting in each customer's namespace, and you can get very custom about what schedule you want them to run on. Lastly, we did the connection to ACCURE's Elk stack with Fluent Bit, where we're sending logs to Elasticsearch and then metric beat for Prometheus metrics. Here is a diagram of the Kubernetes cluster. I'll first draw attention to these customer namespaces on the far right. So each one of these, there are a couple sections. One is the workflow template, then the cron workflow template, then the customer-specific configuration. And this is replicated across each of ACCURE's customers, where there's specific things for each customer sitting in that customer's namespace. If we look in the middle, we've labeled this cluster scope. So some of these are like truly cluster scope things, like the cluster workflow template, where they really don't sit in a namespace. The Argo controller and Argo server do sit in a namespace, either the default namespace or in the Argo namespace. But the broader point is that they're installed with the cluster scope, meaning that they have the ability to orchestrate different workflows running in different namespaces. And then lastly, there are several configurations namespaces for like logging, ingress, metrics, things like that. And also we archive the workflow runs in an AWS hosted RDS Postgres database. And we do that just because doing data persistence on Kubernetes still is like a little bit tricky, and it's better to just offload that sort of thing to others for convenience. So now I'll transition back to Severin to do the deep dive on Dask.
Yeah, so I'm getting some feedback. Actually, I guess it's fine now. Okay, so yeah, Dask seems to be, so Dask is obviously the choice that ACCURE made in the very end in terms of how we want to scale out our data pipelines. And what Dask is, for those of you who aren't aware, is it allows for high throughput data pipelines completely in Python. So Dask is developed in Python, and it's Python the whole way through. So it checks our box of staying in Python. And it comes out of the box with a lot of really nice features. So it allows for this multi-domain execution, again, going from sequential execution on a single machine all the way up to distributed execution across many machines in more or less whatever kind of cluster you can imagine. It also allows for both the batch processing context as well as the shared parallel processing context. And especially through the thing called the futures interface of Dask, this is what it allows for the batch processing. This is what we will exemplify later on in this demo for this talk. So alongside things that come specifically with Dask, it also has quite a lot of supporting resources that we were really interested in. So it's quite a large community, quite similar to Argo, actually, similar number of stars on GitLab, or GitHub, excuse me. And it's a growing community, and there are also services that you can go to get some, enterprise-level Dask support, if that's what you're interested in. And if you're actually interested in not having any sort of, or rather dealing with any sort of infrastructure stuff at all, there's also services that can provision clusters for you on your behalf. And ACCURE is also a happy customer of a service called Coiled, which does this for us. There's a few other options in this space as well, such as Saturn Cloud, which I don't particularly have experience with. But they're really nice for the workers who don't really know so much about Kubernetes and cloud, and it meshes well with allowing them to get done the things they need to get done. But of course, Dask doesn't have everything. ACCURE did have to implement a few things around the Dask tool. So one of those things was work avoidance. So when we execute the same task with the same data twice, or more than twice, there's no point in actually recalculating that task because we already have the result for it. So we'd rather just refer to that previous result. And that way we can save some computational resources and therefore money. And of course, we also wanted to connect Dask to our task artifacting system that we've set up on AWS S3, and also our Elk stack as well. So if we hop over to the next slide. Yeah, so once we talk about putting Dask together with Argo, of course, we're talking about creating some kind of workflow. And the simplest way that I've come up, or rather we've come up with putting this together, is what you see here. So we have a pipeline configuration which wraps around a more generic standard Dask scheduler. And the pipeline configuration is something that we would use for one particular product for one particular customer. So one example might be computing the state of health of all batteries for customer, whatever. Next slide, please. So when we use the standard Dask scaler within this pipeline configuration, basically what I'm talking about here is a cluster workflow template, which takes things like the image repo to use for these yellow blocks that you see down below. I'll come to those in a moment. and also configurations for pod resources and various pipeline settings. When you get into the cluster workflow template, it's a fairly simple template, at least in its simplest sense. So actually, it just has 4 or 5 pieces to it. It begins, of course, with initiating the workflow, just doing basic Argo type stuff. And then the first node in the pipeline would actually be creating the Dask scheduler. And the Dask scheduler is the thing that's going to accept tasks to be worked on from the primary pipeline, and it's going to send them to the Dask workers so that they actually get done. And it's also going to do things like making sure all the workers are balanced in terms of how much work they have to do. And it's also going to provide a Dask scheduler, or rather a Dask dashboard as well. So the Dask scheduler will be a daemon template, meaning it'll be available for the whole pipeline until the end of the computation. And so once you have created the Dask scheduler, the next thing to do would be to create the Dask workers. And to do that, you actually have to pass along the IP address of the Dask scheduler. So this is an easy thing to do in Argo Workflows. It's a fairly straightforward configuration. Again, it's also in our example in case you'd like to see how to do that. But basically, for the Dask worker deployment, this will be a resource template which will create a deployment, which spins up however many number of Dask worker pods you would like to use in your cluster. And this will also be a daemon, of course, so that they stay alive until the end of the workflow. On the right, you also see the primary pipeline. This is just a pod which executes a Python script that does Dasky stuff inside of it. And that will talk to the scheduler, which talks to the workers and distribute workloads. Once the primary pipeline finishes, then we will have an on-exit node, which, whether or not the pipeline was successful or encountered an error somewhere through, the on-exit will tear down all the Dask worker deployments, or all the Dask workers, and make sure there's no orphaned resources left over on your cluster. So all the pieces in yellow are actually all the same image. So if we go to the next slide, we can look into that a little bit. So this would be an image which is specific to one particular product. And there's really not much going on inside of this. For example, it could be just built on top of the Python 3.8.8 Buster base image. You just need to pip install things like the Dask module distributed in Boca as core requirements, and then whatever other Python modules your Python pipeline or tasks need. You then can do things like activating environments if you need to. You have to make sure that the Dask scheduler and Dask worker executables are available on the path. And then, of course, you just need to add your Python script. And then to make all of this generic, next slide, please. Yeah, you can add to the pipeline configuration some configurable, or rather some arguments for the specific tag of the image that you want to use, some various pipeline arguments, and also the number of workers you want in your cluster. So if you increase the number of workers, that would, of course, just make your pipeline run faster. But thanks to Dask, it shouldn't necessarily run any different. It would just take a different amount of time. Okay, so if that is more or less clear, we can hop into the example. So for the interactive demo, we have a fairly simple example for you today. Basically, what we'll be doing is we will look at time series data in Spain, time series weather data, specifically for the cities of Madrid, Valencia, Barcelona, Sevilla, and Bilbao. And basically, we want to answer the question, which of these cities is the windiest? Because this is something that people are very curious about. And the way that this is going to run is we have a pipeline which will take a look at all of our timestamps in our data sets. It's then going to send each timestamp one by one to a Dask worker, where a generic Python function will get executed. Of course, in this case, it'll be a very simple one, but you could imagine it could have anything Python inside of it. And what's going to happen inside of this function is that it will look at the weather data at the given time step, and it will just return the city that has the highest wind speed. And then we'll just count all those up, and we will report in the very end which city was most often the windiest. So back to JP to show you where you can find this example.
Great. I'll have my co-founder, Kaylin, if you would please post the link to the repository in the live chat. We've got a link here, but this will take you to a GitHub repository that contains info about this demo or the sample code and the workflows. Specifically, it contains first a sample Argo Workflows installation. A note of caution, this workload that we're about to run is too heavy to run locally on like Docker desktop, Minikube, etc. We tried several times with pretty good computers and were unsuccessfully able to do so. So we recommend using your cloud Kubernetes offering, whether that's Amazon, Google, Azure, DigitalOcean. I don't think it really matters. Additionally, it has the cluster workflow template containing a Dask pipeline, the workflow template that will invoke that cluster workflow template, and then a Dockerized Python pipeline that will schedule tasks on the Dask cluster itself. Additionally, we have some sample weather data that Severin mentioned baked into that Docker image. And Brian, if you would flip to the video, yep, here's the demo.
Yeah, okay, so we will start the demo by applying our cluster workflow template. And so this will be the standard cluster workflow template that I mentioned before, which can more or less scale any Dask pipeline. And you can see the cluster workflow template just through the Argo CLI. There you are. And then next, we will also create the pipeline-specific workflow template, assuming we can spell right. And so along with the template, we'll also create a config map that limits the parallelism of this template to only one at a time. And we'll also create a cron workflow scheduling, because this is, in my opinion, one of the nice aspects of mixing Argo and Dask together. So here you see our Windy City template is scheduled to run every Monday at 1 p.m., for instance. All right, if we want to run our pipeline, we would just submit it through the CLI in the customer namespace. So here you see just us submitting it in the normal way. And yep, so as you might expect, it's a normal pipeline. And you see already that the Dask scheduler is already being generated, and that pod will start coming online in just a couple of moments. Yes. So you can also see this in the UI if you come over there. Yeah, so here we are in the UI. This is the same pipeline. And you can see the Dask scheduler. And you just saw how now it's both deploying the workers at the same time as already starting the primary pipeline. And if we want to check out the Dask dashboard that I mentioned, we'll need to get the pod name of the Dask scheduler, and we'll need to port forward that. So we'll just do that over here in a moment. Yeah, and we'll need to port forward port 8787 because this is the port that, yeah, right there. That's the port that Dask uses for its dashboard. All right, so here you see the dashboard. This pipeline currently has 4 workers configured, and you see those running. And this really highlights where Dask and Argo are a very nice combination, in my opinion. Yes, we have 1,000 time steps scheduled. That's where that 1,000 comes from. Yes, but this really highlights where Dask and Argo is a very nice combination, because each of these tasks are only several hundred milliseconds long. So if each of these, yeah, we have 390 and maybe another 300 somewhere. But if each of these were to be an individual pod, of course, that would greatly extend how long it takes this pipeline to finish. And also, since these pods are so small, it's not really necessary to track them in Argo. The dashboard also shows you live how much the memory usage is of each of your workers and can give you a lot more other really useful information that you could imagine using. Thank you, Gus. I see the dashboard looks beautiful. This doesn't come from me. This comes from the Dask people. Yeah, I could take credit for it. Yeah, so back in the pipeline, you see how once the pipeline finishes, the teardown will begin on the Dask workers. And if we want to see which is the windiest city, we just got to check out the main logs. And you see that the windiest city is Valencia. Who would have guessed? at least for the first 1,000 time steps of our data set. So we mentioned that this pipeline is configurable, so we can come back over to the CLI and we can increase the number of workers and also make the pipeline a little bit more intensive. So if we do that, just a moment. Yeah, first I would prove to us that we have only one node running at the moment. So that will become relevant in just a few moments. So yes, we will submit the pipeline, and this time we will set the number of workers to 50 and the max time steps to 10,000 as opposed to 1,000 this time. And these are, of course, arguments that that we have configured in the pipeline itself. So once again, here's the Dask scheduler. We'll get the pod name, we'll do the port forwarding thing, and then we can see how that has changed. Yes. All right, so once we refresh this page, we'll get into the new dashboard, and immediately you can see that there are more workers, definitely not 50 workers. That's because the nodes that have the other workers are still spinning up. So if we take a look at the number of nodes, we have a regular autoscaler attached to this cluster, which I don't know if I've mentioned until now. This is actually running on AWS EKS. So there's an autoscaler running in here, and it'll, of course, understand that more pods have been requested than what the current nodes are capable of. So it's going to start spinning up the nodes now, which you can see. And I guess there will be 4 or 5 nodes in total in the end. Yes, and Dask is really nice in the sense that it actually will respond dynamically to new workers coming online. So if we actually take a look right now at the pods inside of this namespace, you can see that we have still 50 nodes, but many of them are in the pending or container creating state, and they're not yet active on our pipeline. But if we wait just a couple of moments, we should start seeing those coming online. And if you look on the bottom left, you'll also see that the tasks processing per worker will also get redistributed as soon as more workers come up.
There we go.
Yep, there we are. And this actually meshes really nicely with using like spot instances and things like that in your Kubernetes clusters, because if your nodes come up and down over the process or over the timeline of your workflow, then actually Dask will be resilient to that. So yeah, here we are scaling out. Looks like we're up to 50 nodes or 50 workers now, and you can see that same exact pipeline is running, but now just quite a bit faster. Yep, and also still in the range of 400 milliseconds per task. Yes, okay, so another nice feature of mixing Argo plus Dask is that since we have this parallelization limit set inside of Argo, if we were to now submit the same workflow several times, of course, these will stay in the pending state, and they won't actually start running anything. So if these tasks were, for example, talking to a database or hitting an API, something like that, you would be protected from overwhelming your database or the API. So there's some nice control there, and you don't get that from Dask. That's definitely obviously an Argo feature. And here you see that the other pipelines are just waiting for the first one to finish. So that's quite nice. Yeah, and so this is of course a very, very simple example. But Dask can scale up easily to hundreds of workers, and the size of those workers is just a pod configuration. So they can be as large or as small as you want, really limited by the Kubernetes cluster that you're working with. And the functions themselves can be total black box functions. So you could put whatever simple or complex things you want to put in there. And yeah, once we take a look at the first 10,000 steps, you see that the windiest city is now Barcelona. So Barcelona is the eventual winner. All right, and that's more or less our demo. So we can hop back over to the slides.
Yep, thanks, Brian.
Yes, so just a few concluding remarks before hopping over to questions, if there are some. So basically, the question should come up, when is it right to use Argo Workflows plus Dask, and when is it not to? So for us, this is, of course, just in our experience, but we tend to differentiate between when we are dealing with scheduled, well-defined type scenarios versus exploratory ad hoc scenarios. And when we're in this scheduling automated workflow space, we really feel like this Argo plus Dask is great because we control all the variables. We control when pipelines run, we control how big the workers are, and we can do, we can add other things like Slack notifications and other contingencies to our pipeline, making a more complex standard Dask scalar workflow. But when we have humans in the loop, such as if a data engineer is doing some development on a big pipeline, or they're doing some exploratory type analysis, then we find that these Dask as a service type tools that I mentioned previously tend to be better suited for this sort of task. So we found that this tends to provide for faster development iteration speeds, and also it empowers our data engineers to completely service themselves in terms of setting up large clusters and getting them working for themselves. And again, these are people who don't really know Kubernetes, don't really know cloud. They just want to stick in the Python space. Yeah, and so beyond that, it's important to note that Dask is not a silver bullet. Obviously, we really like it, but there are some skeletons in the closet. So one of the things that we've noticed is that there are some instabilities for particularly long-running tasks. And in general, we've seen that tasks that take hours are pretty much okay, whereas tasks that take days are questionable. Like unexpected problems tend to come up in that sort of a case. Also, Dask can do batch processing, but it really excels at this shared parallel processing type scenario, especially with the Dask data frame interface. And I would go so far as to say that this is kind of like the main point of Dask. So if you are like ACCURE and you know for sure that you want to be operating in both of these spaces, then Dask is a very good tool to use. However, if you were only doing batch processing, you might consider using something else because you probably would get better stability, maybe at the cost of a little bit higher complexity, but pros and cons. But even with that, it's important to mention again that Dask is a active project, and if you are particularly interested in using Dask in this sort of a way, and you want to see some of these points improve, then I would say that I would really encourage you to get involved in the community, because more interest in this sort of use case would definitely help shift the development team of Dask over to this. So don't hesitate. And with that, I would say we're done. So you want to contact either myself or JP, and here's our contact information. And otherwise, questions are welcome.
Yeah, that was great, guys. I appreciate that. We've got some questions that are over in your session chat. So if you want to jump over there and answer them, or there's questions that are streaming in through the CNCF Slack channels, you can find those questions there. That demo was really, really entertaining. So thank you both. And I'm from Texas, so the Texas Tech reference, I was like, yes, that's amazing. All right, gentlemen, thank you both for your time today. Those of you that are still in the audience, if you haven't filled out the survey, please do so. We want to know how you're using Argo right now and in the future. And then we also want to make ArgoCon 2022 amazing for you. So let your voice be heard, and then join the chat. Thanks, y'all.